Today we are listening to Apollon Oikonomopoulos, speaking about the Ganeti Cluster Virtualization Manager, past, present, and future. We look forward to hearing from your talk.
Thank you very much. Good afternoon. Thanks for coming. This is a talk about Ganeti. It's not a new software, but there are some interesting things going on in the project itself, which I wanted to share. So we'll do a short introduction to Ganeti and then look a bit at the history of the project, its current status, and what we want to improve in the future. So just a brief introduction. I'm Apollon. I've been a Debian developer since 2014. I'm also contributing to Ganeti, and I maintain the package in Debian. And my personal interests are more on the systems and network side of things. And for a living, I'm a director of platform engineering at ScrewGR, which is a Greek e-commerce platform. So, who of you has heard of Ganeti here? Okay, so that's quite a lot. How many have used it? Good. Okay, so Ganeti is labeled as a cluster virtualization manager. What it does is that it supports KVM and Xen instances, and it tries to manage a cluster of machines, which it calls nodes in Ganeti terms, as a non-uniform resource pool. So if you have, let's say, 5 machines that you want to run your VMs on, what Ganeti does for you is that it creates a nice abstraction layer on top of them, and you don't have to care which VM runs on which machine. It's just managed automatically. You just say, I want a virtual machine with that much memory and that many CPU cores, and then Ganeti does the rest by managing the actual host itself. So as a software, it's rather self-contained, so it has little external dependencies, and it's not a huge code base. So it's let's say, rather moderately sized. And it focuses heavily on availability and manageability. We'll talk about this a bit more later. So a couple of the distinctive features it has that make it stand apart from other solutions is that it has many, let's say, high availability features. The most prominent being the out-of-the-box support for DRBD and Ceph-backed instances. So with DRBD, you basically get your virtual machine data replicated on 2 nodes, which can then be used to live migrate or fail over the machine. And you also get that, of course, when you use Ceph with RBD, which is distributed by nature. And also it supports a number of live operations on the instances, which means that you can actually tweak the instance configuration without downtime. You can add network cards and disks and remove them at runtime, and also supports memory ballooning so that the VM memory can be increased or reduced according to needs. And finally, it also has some built-in auto repair functionality. So it can easily restart machines that should be up, but they're not running for some reason. And it can also, to a limited extent, repair the cluster state by migrating or failing over instances from dead nodes if need arises. So one of the core design decisions while first writing Ganeti was that there should be no single points of failure. So as an architecture, a failure in Ganeti should not impact running instances ever. So it's loosely coupled to the hypervisor, but at the same time in full control. And the good thing is that Ganeti processes can be stopped or restarted without affecting any running instances, even to the extent that you can upgrade the whole cluster to a newer version without impacting any running VMs. And another thing that's not that common in that kind of solutions is that each node actually bridges and or routes the traffic for the instances it's running by itself. So instance traffic is not tunneled through a single system that could act as a single point of failure. All in all, it's a fairly resilient solution. And my personal experience with it after running Ganeti clusters for the past 10 years is that we've never had a single outage that was Ganeti's fault. So as far as networking goes, of course it supports instances with multiple network cards. On a cluster level, it has the ability to separate storage and data and replication traffic over 2 different networks. And it supports bridge and routed guest networking. It has limited Open vSwitch support currently, so it supports tagged VLAN interfaces, but not VXLAN. This is something that needs to be implemented yet. And the good thing when running a standalone cluster in, let's say, a moderately sized cluster for a small, medium company is that it also can do its own IP address management via GNT network. So you just configure a subnet that's used by Ganeti for the instances, and then it does all address allocation and configuration on its own. Unlike what happens in public cloud solutions, it has no elastic IPs or mappings of any kind, but I mean, these can be implemented externally. So as I said, Ganeti has a strong focus on manageability. It's built primarily for sysadmins and less for end users. So it has a comprehensive command line interface, and it also has a quasi-RESTful, well, sort of, HTTP API, which can be used to perform most operations on instances. There is even a Python client library that can be used to abstract away the API details themselves. What it doesn't do is that it has no notion of users, so the resources are just there as long as you have access to the API or access to the command line interface. If you need to implement any user or multi-tenancy, then this has to be done externally. And there are many third-party web interfaces that do that by tagging instances as belonging to specific users, but it's not something that is part of Ganeti core itself. So as I said, there are some third-party web interfaces, one of them being Ganeti Manager, Ganeti Web Manager. These are 2 different projects. And then there is Cinefo, which is a front-end initially created for the public cloud of GRNet, the Greek Research and Education Network, which relies on Ganeti. All of them are free software and can be installed in parallel with Ganeti. So when it comes to instance provisioning, so how do we install an operating system on an instance? It has its own system. Ganeti has a concept called OS provider, which is basically a set of scripts that know how to partition a disk and install an operating system. Cluster can have more than one OS providers depending on what you need to do, and you choose one which is supposed to provision a new instance at the instance creation time. It looks more like a hook-based interface, so it's one script per action, one script to create the instance, one script to reinstall it, and one script to do a backup of the instance if need arises. And these scripts can support variants. For instance, you can have a Debian OS provider that has a variant for Stretch and one for Buster and then one for Bullseye. And they also get a set of parameters which can be relayed to the instance. For instance, what is your host name or any special configuration that should be done. And it also supports secrets that are transmitted to the instance without being logged anywhere. So it's fairly comprehensive interface. It's just that it's completely Ganeti specific. There is a good documentation about it. There is even a man page about it that anyone interested can have a look at. So examples of OS providers that are out there is Ganeti Instance Bootstrap, which is also available in Debian, and uses the Bootstrap to create the root file system for an instance. There's Ganeti Instance Image, which is, as the name suggests, image related. So you have ready images of instance disks, and it takes care of installing them. And then there is Ganeti OS No-Op, which is a completely dummy OS provider that does nothing, but is there just to circumvent Ganeti's need for specifying an OS provider. So this is used if you import a new, an existing machine into Ganeti and just don't want Ganeti to mess with the operating system in any way. So code-wise, Ganeti is a relatively mature project. So it has been around for, let's say, 12 or 13 years. It's written in Haskell and Python, which is an interesting combination. The biggest part of it is Python still, but there is a sizable part that is also Haskell, and we're looking for said contributors apparently. With those 39 lines, we would like to see more. And the way it's the way the barrier between Haskell and Python works is anything that does low-level system stuff, for instance, manipulating DRBD disks or creating LVM disks or starting and stopping the instances is implemented in Python. The whole, let's say, business logic stuff and the work queue and the central control that does the cluster management is implemented in Haskell. We'll talk a bit about this later, but this has some very interesting side effects. So Ganeti node D, which is mentioned alongside Python there, is what runs on every node, and the Haskell daemons run basically on the master node, which takes care of controlling the cluster. So according to the stats in GitHub, the current repository has 127 authors, and it weighs in at 16,000 commits. That's for the full 13-year history. So, what makes Ganeti special, and is there a special place for it in today's market? So, apparently Ganeti is not OpenStack, and it's not Kubernetes either. There's no real container support. There is some support for LXC, but it should be considered experimental right now. The thing telling Ganeti apart from any of these is that it's way simpler and self-contained, and it's aimed at running long-lived guests. So OpenStack is more tailored towards implementing a public cloud-like setup, and Kubernetes obviously solves a completely different problem. So Ganeti tries to scale well from clusters of 2 to several hundreds of nodes and several thousands of instances. For instance, at work we have our main cluster currently runs 500 instances, if I recall correctly. And it's a great way to run anything that should be long-lived with disaster recovery guarantees. So it's great for running things like mail servers, database servers, and it's also a good solution to run your Docker hosts and Kubernetes nodes. Being able to live migrate things obviously means that you get less downtime for services that do not provide application level redundancy. And the good thing with it anyway is that it abstracts the hardware and allows you to keep state where you need it. So as far as Debian is concerned, the Ganeti has been in Debian since Lenny. It's a team-maintained package. Currently, the team has 3 members, I guess, but we always welcome more. And you can have a look at the packages that's there on Salsa. And what we have currently as a set of packages is version packages. So Ganeti has a compatibility promise that says that instances with the same, nodes with the same minor version, so 2.15.1 and 2.15.2 should be interoperable. But we break the APIs with minor versions. So 2.16 is not runtime compatible with 2.15. So the way we handle upgrades is because you need to get all nodes upgraded at once. Ganeti provides a mechanism for this. And in Debian, we have the same, we have packages that can be co-installed. So you can run 2.15 and 2.16 at the same time. You can have them installed on one machine and then choose to upgrade the whole cluster at once through a mechanism via GNT cluster upgrade. So apart from being available in Debian, it's also used by Debian. The Debian system administrators use it to run much of the project infrastructure. This includes most build-Ds and a lot of other systems. And we even have some virtual machines on non-Intel architectures, which I find kind of interesting. Of course, we needed to do some patching there. It didn't work out of the box, but we are, as far as I know, we're running Ganeti PPC 64EL and ARM64 instances right now. At this point, I would like to give a bit of context regarding the project's history. In the early days, it started as an internal Google SRE project. And as far as I remember, there were 2 Debian developers on the team. One of them was Guido back there. And initially, it consisted of a set of scripts to manage DRBD-backed Zen instances. That was the days of Ganeti 1. And the authors were kind enough to release this as free software in 2007 under GPLv2, which later got relicensed under a BSD2 close license. And back then, it was written entirely in Python. So in that form, it has been part of Debian since Lenny, and it appeared during the Lenny development cycle, I think. So that was back in 2007. Around 2010, it gained good traction. It was a time where OpenNebula appeared, and Eucalyptus was also a thing, and it was just like AWS was becoming a thing, and people were trying to set up their own virtualization clusters. So at the time, it was seen as a good alternative to Eucalyptus and OpenNebula. And that's the time the DSA started using it for Debian infrastructure, and a few companies, including mine, started to host internal stuff. And it was even used to implement public clouds in Greece, which is pretty big, with several tens of thousands of instances. So, although this was essentially a free software project, development was always led by Google. There was a team that was at least part-time dedicated to it, and outside contributions were always, of course, encouraged. And in fact, a number of features, for instance, the whole GNT network thing that does the IP address management, was implemented by external contributors. By 2013, if I recall correctly, it was promoted to a full-time software engineering project, which means it got its own dedicated team that did that and nothing else. Before that, it was people doing both development and operations and possibly other things. Now it got a team that was dedicated to developing it as a software project. So under that status, and during 2013 and until 2015, it was when many core components were rewritten in Haskell. So the rationale there was that Ganeti needed to have better performance than Python, which was somewhat limiting, especially when it comes to threading and doing things in parallel. And it was also Haskell's guarantees of safety due to purity and strong typing that seemed interesting. So I have to say that in the, let's say, 7 or 8 years that I've been maintaining the package, the Haskell code has given us the least problems, probably, up until recently, where it completely broke because of the transition to Haskell 8. So eventually, due to internal changes at Google, development slowed down by the end of 2015 or mid-2016, and it essentially stopped by the end of 2016. The thing is, there was a sizable community that had been that had developed around the project, and even had an annual users meeting, which we call Ganeticon. And the community went on holding Ganeticon every year since then, and submitting issues and pull requests, which remained in a limbo for quite some time. So the latest development there was that in December 2018, 2.16.0 was released, and Google officially announced that it was ending development. There will be no more Google-initiated releases of Ganeti. So this leads us to now, basically. We, as a community of users, are trying to take over the project and continue from where Google left. So it's the procedure to hand over the project has been a bit slow, but it's picking up speed. And we're in a process of talking with Google to get the project assets transferred to the community. This includes a GitHub account and things like the domain and so on. So at the same time, we're also trying to restart development because there are things that the code base is getting older, and there are things that need to be fixed, and compatibility that needs to be implemented. So there's a lot to be done, and unfortunately, there is currently few people involved. So if anybody is interested, please step up and say so. The community efforts led to the release of 2.16.1, which was released this April, and it included code from 17 different contributors. Now, in reality, it was 5 or 6 people. The rest was cherry picks from older branches, but it was 5 or 6 people that actively contributed code during these 4 months, which is not bad. So this was the first release outside Google, and the aim was to fix long-standing bugs and add support for modern Haskell and QEMU 3.1, which was released with Buster and broke a lot of options. So 2.16.1 basically reduced the delta with the Debian package a lot. It removed 24 patches from the package, which were merged upstream. And this got us to Buster. Unfortunately, it was too late to get 2.16.1 in Buster, so the package in Buster is still the heavily patched 2.16.0. But I plan to update this via backports in the short-term future. So Stretch was released with 2.15.2, but also has 2.16.0 via backports currently. So there is an upgrade path for people wanting to upgrade via backports as well. So what do we expect to improve in the near future, given enough human resources? So the first and most obvious thing is that we need to move away from Python 2. Python 2 is end of life by end of this year, and there is no reason to lag behind. It's an inevitable reality. Unfortunately, that's not an easy task. Migrating a relatively big code base from Python 2 to Python 3 is not just about replacing all instances of the print statement with the print function. The biggest thing with Python 3 is that it has an internal boundary of strings and bytes. Anything that is communicated with the outside world is bytes, and the application internally has to work with strings. This is something that didn't exist in the Python 2 world, and it means that you have to carve out a boundary between your application space and the rest of the world. So this is fairly intrusive if you want to do it right. This is something that is underway. We've reached a point where all tests pass with Python 3, but it needs rigorous testing. The problem with Python here is that we expect a lot of things to break at runtime. Because of duck typing, there is no such thing as static type checking that you could use to see if you've got everything right. And because of Ganeti's nature of interfacing with low-level systems components, you can't just mock all of these systems away and expect unit tests to work. So we need to do rigorous real-world testing and regression testing to get things right. Another thing is that while the OS provider thing works well if you have the resources and power to actually maintain your own images, it doesn't provide a very smooth experience out of the box. So, for a start, all image-based providers require maintaining your own images, and this is quite a lot of work to do if you want to do other things on the side. So we've been asking ourselves, since our own wheel does not roll better, why not use ready cloud images instead? There are different solutions out there. We're mostly compatible with anything that runs on QEMU, so we could, for instance, use even Amazon AMIs. So the project should focus on a blessed, let's say, default OS provider interoperating with, I don't know, for instance, OpenStack images. We're not completely sure about this yet. It's still something that the discussion is in progress, but it's a step that has to be taken forward. The other thing is improved hypervisor support. So what we are basically relying on is QEMU and Zen, but I mean, the census out there says that it's QEMU and KVM that most people are using. So QEMU has been advancing pretty fast, and the Ganeti's defaults haven't been updated since, let's say, 2011 or 2012. So we need to get better out-of-the-box defaults to give a more smooth experience and leverage newer virtual hardware generations that QEMU has to offer. For instance, we are running on emulated i440 chipsets by default, which is a Pentium 2 class system with a plain PCI bus. We could switch right away to Q35 and PCI Express, which would give a much better experience and support for various VirtIO devices. Other improvements that the users have been asking for is UEFI support, among others, will help enable secure boot on the VMs and so on, or even QBoot, which is QEMU-specific firmware that tries to minimize startup times. So, but for me, the most important thing is to establish a communication channel with the QEMU development and stay up to date. We only noticed the breakage of QEMU 3.1 when QEMU 3.1 was out, but we should have known better and we should have been notified earlier. And of course, taking the project from corporate to community development is really hard. Google was doing all the release engineering and feature planning and was driving the project ahead, and now we have to somehow substitute for this. And it's something that leaves a big gap. And given the fact that also old code bases barely attract new contributors, we're in a relatively tight spot. But there seems to be some still interest in the project, and people are stepping up to help. So one other problem is that the choice of Haskell obviously offers some great advantages. As I said, it's been one of the less troublesome components I've seen, but the problem is that it raises the bar for contributions. So people who deal with systems programming do not usually write Haskell. And to be honest, if you are just a systems administrator or an SRE, Haskell may appear at least daunting at first sight. So this is something that has been discussed over and over in the recent Ganeti conferences. If we want to keep Haskell around or replace it, for instance, with Python 3, with recent patches to get compatibility for GHC 8. This has been less of an issue, but still it's something that needs to be considered. And of course, we need to figure out project governance and processes to prioritize features and do release engineering. 2.16.1 worked because there were many low-hanging fruits, but in the future, especially for 3.0, which is going to be the next major release, we need to make sure that we can do some proper planning. And finally, of course, we need to reach out to anyone who can help. The project is big. There is a sizable user base. Unfortunately, most of the users do not contribute in terms of code, but still there's a chance to contribute either by reporting bugs or documenting things or even conducting some testing. So if anybody is interested, I find Ganeti terribly interesting project to work on. You get to deal with a distributed system that also does virtualization. It's not containers, but it's still very interesting stuff. So if anybody wants to contribute, your help is really, really, really appreciated. So that's all. I think we have enough time for questions. Thank you very much.
Hi, great talk, thank you. So at DayJob, we have many independent Zen servers. They are not clustered in any way. We don't use DRDB. Is there any way that Ganeti can adopt those VMs without any downtime?
Yes, but it's not that straightforward. I mean, under the hood, it stores all state in a big config file, which is distributed between nodes. And it's the config file is pure JSON. So in theory, you can generate a config file for your current state, and it should be able to more or less adopt things. But it depends on your specific setup. And there's also, I don't know if are you using shared storage?
No.
No.
Well, we have a cluster server, but it's not tied with the Zen server.
Okay.
Yeah.
So newer Ganeti versions also support what is called external storage providers, and yeah, so you can also write some scripts that set up and tear down storage for the instances, leaving just a symlink to where the instance disk should be. So that's the API. There's a symlink to the device that should be the instance's disk. So you can also leverage that to import your storage into Ganeti if you have special needs there. I know that other people have used that to implement providers for storage providers for big SAN devices, for instance. But yeah, I mean, it's something that you could explore. It's not that difficult. For the most part, the config is human readable. You just need to generate UUIDs and stuff if you want to, make it work. But it's something you could explore, and for sure it will be a big improvement over hand-managed Zen servers.
Thank you.
Welcome. Other questions? Nope. Okay. Thank you very much.
Thank you.